All right, moving on to section 2.2. So now we're going to be solving equations that require two steps. All right, so again, after this lesson, you should be able to determine if the value of a variable is a solution to an equation, and you should be able to solve an equation in two steps. All right, so for these, all right, here's kind of a step-by-step approach to how you're going to solve these equations. All right, so again, remember, the ultimate goal here is to get the variable on one side of the equation by itself. Right? When you're solving an equation, right, your ultimate goal here is to do that. Right? Get the variable on one side of the equation by itself. So now we're going to see that if there are fractions, and we've already seen some equations in lessons and homework where there's fractions. All right, so if there are fractions as either a coefficient of a variable or a factor in front of a parentheses, then we need to make sure that we clear them out. Okay, so we're going to go through some examples how we're going to clear out the fractions. All right, and here's the method you're going to do that is that you're going to multiply each term. So this is an important part here. When you are looking to clear out fractions, you have to make sure you understand that you're going to clear out the fraction by multiplying each term by a common denominator of all fractions involved in the equation. Okay. Next, you're going to simplify both sides of the equal sign, meaning you're going to do things like you're going to distribute, right, to get rid of parentheses, and then you're also going to combine like terms. Right? So again, we're looking at both left and right side of the equal sign. We are looking to simplify. So that means, again, to distribute, we have parentheses, and to combine like terms. All right, once you're done with that, then we're going to isolate the variable on one side of the equal sign. Now, again, it doesn't matter which side, either the left side or the right side. Again, we're going to isolate it by, as we talked about in 2.1, we're going to undo operations. We're going to undo addition and subtraction first, and then we're going to undo any multiplication or division. Okay. All right, so let's take a look at example 1, where here we have equations that, right, we're noticing do not have fractions. Okay, so we're going to totally skip step 1, right, in that step process above, because there are no fractions to clear out. And we're also going to skip step 2, which says simplify each side, because we're looking at the left side of the equal sign, and we're seeing that, okay, there's no parentheses to distribute anything. There's no like terms to combine. Same thing on the right side. Right? There's nothing to do in terms of simplifying each side of the equal sign. Okay, so then we're going to move on to step 3, which says, all right, we got to undo operations. So we're looking to isolate the variable. All right. All right, so first thing we need to undo is any addition or subtraction. Here we have plus 9, so we're going to undo that. Again, you're going to show me that, right, that you're subtracting 9 from both sides of the equal sign. Left with 5x on the left and 15 on the right. Now we're going to undo the multiplication because this is 5 times x. To get x by itself, we are going to do the inverse or the opposite operation, which is division. So we're going to divide both sides by 5, and we get x is equal to 3. All right, moving on to part B. Again, we're checking to see, are there any fractions? No. So we're skipping step 1. Check the left side. Can I do any distributive property? Nope. Can I combine any like terms? No. Same thing with the right side. All right, so then we're moving on to step 3, which is let's start undoing some operations. Remember, we're looking to undo addition and subtraction first. So here we have this plus 3. We're going to undo that addition by subtracting 3 to both sides. This is negative 5 times x. So we're going to undo that multiplication by division. So we're left with x equals 3. Part C. No fractions to clear out, nothing to distribute or simplify. So now we're looking to undo. All right, so let me give you some time here to see what you can do with problem D. All right, so for part D, we're going to undo any addition or subtraction. So the first thing we're going to do here is actually add 3 to both sides to get negative 5x. That's left on the left side, negative 29 on the right. To get rid of that negative 5, since it's being multiplied to x, we're going to divide it out. Right? We're going to undo the multiplication last. So we're going to divide both sides by negative 5. We got x by itself on the left. Now, since 5 cannot go into 29 evenly, we're going to leave it as a fraction, as an improper fraction, 29 over 5. All right, I'm going to skip over to problem F. So here we have an equation that has a fraction in it. So we're not going to skip step 1. So we want to clear out the fraction. All right, so again, if you look back at the notes on the previous page, it said that we're going to clear out fractions by multiplying each term in the equation by a common denominator. Well, there's only one fraction, so there's only one denominator, and that denominator is 2. So to clear out the fraction in this equation, we're going to multiply every term by 2. All right, so now recall that terms are separated by plus or minus signs. So on the left side, there are 2 terms. On the right side of the equation, there's only 1 term. As you can see here, I wrote that I'm multiplying all 3 of those terms by 2. Right? And again, to clear out the fraction, we're going to multiply every term by a denominator value. So in this case, again, it's 2. So 2 times 14 is 28. Now when we get to the fraction, right, again, what's going to happen when you multiply a fraction by whatever is in the denominator, those are going to simplify or cancel. Right, so those 2's go away. So now we're just left with P. Again, even though 24 is not a fraction, right, the rule is once we decide how we're going to clear out fractions and what we're going to multiply by, everything, every term gets multiplied by that number. Okay, so as you can see here, now we're looking at an equation that doesn't have any fractions. Okay, so this is where you want to be when you start moving on down to the remaining steps. Said, okay, I don't have anything to distribute. I don't have any like terms on each side of the equal signs to simplify. So now I'm going to go ahead and undo operations. This 28 is being added to P, so I'm going to undo that addition by subtracting 28. So I'm left with P equals 20. All right, moving on to G. Again, we do have a fraction here. Now this one's a little different than what we saw in the previous examples in 2.1. Right? And we might be thinking that we might want to multiply by the reciprocal here. All right, but because of this minus 8, we want to be careful what we do in terms of clearing out the fractions. Right? So in situations like this, let's stick to the plan. And the plan is, okay, if we want to clear out fractions in the beginning, and we do, we're going to multiply every term by a common denominator. There's only one denominator. It's 3. So we need to multiply every term by that 3. All right, so when we multiply the first term by 3, the 3's cancel, right? Especially the one that's in the denominator of that fraction. So I'm left with 2x. And then everything else gets multiplied by 3, even though they are not fractions. All right, so we get a negative 24, and then a negative 42 on the other side of the equal sign. Okay, so that, again, that's going to leave us now with a fraction-free equation. All right, so then when you undo the operations, so we're going to add 24 to both sides. Then we get 2x is equal to negative 18. Divide both sides by 2. X is equal to negative 9. All right, let's see what you can do with problem H on your own. So again, we want to follow through the steps of how we're going to solve this equation that has a fraction in it. All right, so to clear out the fraction, you should be multiplying every term in that equation by 5. All right, because that's what's in the denominator of the one fraction that's in the equation. So again, everything gets multiplied by 5. Every term gets multiplied by 5. All right, so that first term, when you multiply by 5, the 5's cancel, so you're left with 3 times x. The next term you multiply by 5 gives you 45. And the other term on the right side, when you multiply by 5, gives you 75. Okay, so again, that leaves you with an equation where you're going to undo the operations. Right? You don't have to worry about fractions. Everything's simplified on the left. Everything's simplified on the right. Right? Subtract 45 from both sides. You're left with 3x equals 30. Divide both sides by 3. X is equal to 10. So now we get to problem I, where we have now 2 fractions in our equation. So now we got to remember, if we're going to clear out these fractions, and we want to clear both of them out for sure, that we need to pick a number, right? A single number that we're going to multiply every term by, that's going to clear out both fractions at the same time. So now the common mistake here is that students are going to multiply, that one fraction on the left by 3 to get rid of the 3 in the denominator. And they're going to multiply the fraction on the right by 4, right? Again, you cannot multiply 2 different numbers in the situation. You have to pick a number that is going to clear out both fractions at the same time. Okay, so now again, we're looking for a common denominator. So we're looking at 3 and 4, and we're thinking, okay, what is a small enough number that 3 and 4 go into? Okay. And that number is 12, right? So we're going to multiply everything through every term by 12. Okay, so we're going to multiply everything through by 12, right? So we're multiplying every term by that same number. Now, with this fraction, we got to be careful. So we know for sure that with this 3 down here is going to get canceled, right? It's going to get reduced, right? But this 12 is not going to go away totally. It's going to get reduced down to a 4, right? Because 3 goes into 12 4 times. So now I'm left with this 4. So what do I need to do with that? Well, I'm going to multiply that 4 times the 2 and then times the x to get 8x. Okay, so again, this 12 did not go away totally. 3 down here did, all right, but we need to make sure that we're reducing the 12 up here. Here, the 4 and the 12 we're going to multiply by together. Right? There's no fraction there, so that's just 4 times 12. And on this side of the equal sign, this 4 is going to go away in the denominator, but this 12 is going to get reduced down to a 3, because 4 divided into 12 leaves you with 3. All right. And what you do with that 3 is we're going to multiply with this 3 and then that's left in the numerator of the fraction. So 3 times 3 is 9. Okay, so that's what's going to happen there when we multiply every single term by 12. We've cleared out the fraction. All right, so when we solve that equation for x, we're left with x is equal to 57 over 8. All right, so that's it for today. Go into the homework. If you have any questions, need any help, let me know.